Our next guest speaker is Michael James. Michael is the Director of Origin Fire Consultants. He is also President of the Society of Fire Protection Engineers. He has a passion for preparing sound and innovative fire engineering and fire protection designs for all types of buildings. He has also developed a methodology and in conjunction with Auckland Council for assessing and rectifying passive fire defects in existing buildings. Michael will talk about passive fire protection for subdivided houses, terraced houses and apartments. Can we give a warm welcome to Michael?
Thank you and hello everyone. So as a fire engineer I walk into this room and I look up in the ceiling and I see a smoke detector and I go tick. And then I look at the back door and I see an exit sign and I see it over some sliding doors and I go half a tick. And then I look at the other exit and the doors are opening inwards instead of outwards and another half tick. But that maybe complies as an alternative solution because it's chocked open and we can all zip through there, no problems. So let me get my presentation up. Find it. Okay, so passive fire protection for terraced houses and apartments. Can I just do a quick poll? What things do you build? How many people primarily are building houses or houses subdivided into two houses? Okay, and people doing terraced houses? A few people. Anyone doing apartments? A few people. A lot of these things, they're quite generic to all of them, but I'll focus more on sort of single houses with a wall in between and things like that. So, just tell you a little bit about ourselves, Origin Fire, methods of compliance, what is passive fire protection. We may have some simple ideas, but it covers quite a broad scope. Ideal design and construction methodology. This is something I'm quite passionate about. In the past, we did no design, and when we got to construction, we didn't do any design during construction, and we got what we got, and generally we didn't get what we thought we would like. Then I'm going to tell you about some typical problem areas or areas that need to be looked at, and some smart ideas for making life easier for everyone. So, a bit about ourselves, Origin Fire Consultants. We started off as part of Pacific Consultants. They are a building services consultancy. So I was in charge or owned the Auckland Fire Engineering team from 1999. In 2015, I decided that if you wanted to find a fire engineer, you didn't go looking inside a building services company. So I rebranded, and so that's where we have Origin Fire. But just to show you that we've been interested in fire for a long time. A bit about myself. Oh no, sorry, we've missed that. Oh, company. So we have 10 staff. We do fire reports, which maybe you're all familiar with. We do fire protection, which is sprinklers and alarms. And we do passive fire protection, which is anything to do with fire-rated construction or penetration, so that means walls, anything that's not moving. Some large projects we've done, Library Lane Stage 1, when we started that was the biggest apartment block on the go, but there are many of similar size around Auckland now. Small projects, single house, someone wants to put a granny flat or subdivide it. I would say of the two projects, subdividing a single house is probably the most complicated, time-consuming and frustrating project that we get involved in. Some more interesting ones, the pop-up globe, which you've probably seen, and we've been doing some underwater structures in the Maldives. I've been pushing hard to go and inspect those, but haven't quite been invited. The client just doesn't seem to be able to get there. Myself, I started out as a draftsperson, then a building services engineer, and for the last 20 years I've been a fire safety engineer. And as was mentioned, currently the president of the New Zealand branch of the Society of Fire Protection Engineers. So there's a number of routes of demonstrating compliance with our buildings. So the simple one is the cookbook approach, where we have an acceptable solution, we follow the rules and we get the answer. For single houses and terraced houses, this is what we use a lot. It's pretty adequate. For larger buildings, we can have a verification method, which is like an advanced cookbook. It tells you how to do the calculations, but you have a bit more flexibility in what you do. Then we have alternative solutions, where as long as you comply with the building code, you can do whatever you want. In houses and terraced houses, it's pretty hard to justify the budget to do something like that. However, when we are doing alterations to buildings, then we need to comply as near as reasonably practical. And how we go about demonstrating that as near as reasonably practical, we can use any of those three methods in combination. So we might use some calculations or arguments or modelling. All these things come into play. So the two main acceptable solutions for the buildings that you're interested in, CAS1 is for single houses, houses subdivided into two, simple terraced houses, and houses on two levels as long as they have their own means of escape. And CAS1 is written so that maybe anyone can use CAS1. I think it's true, anyone can use CAS1. And if you're doing a terraced house, it's easy for a fire engineer to write a fire report and they put a single line between the two terraces and say, fire rate that, job done, collect the money. And that's sort of the beginning of where the design process goes. And that's what CAS1 would tell you to do. But how you build that firewall, that's where the fun starts. CAS2 is for those residential buildings that are in sleeping accommodation that are more complicated. It has more rules and regulations that develop on the fundamentals in CAS1. So CAS1 has some things in it that you can't actually demonstrate are safe, but it decided that are pragmatic solutions for building houses. And when we were in the business of just building single houses, it was probably quite right. But you can now extrapolate CAS1 to do quite large developments. And what might seem safe for a single house isn't necessarily safe when you push it to the max and you squash a whole lot of buildings altogether. But that's the rules as it is that we play with. So there's a number of facets that go into fire protection. We have active fire protection, sprinklers and alarms, and passive fire protection. We have fire rated walls, we have fire rated floors, we have fire rating of penetrations that go through those. And then the third circle I've got there, ongoing maintenance. I think in the presentation before, there was a little bit of discussion about maintenance. Well, fire is the same thing. You can't just build it and forget it. If that door, for example, was a fire door and you put a chock underneath it and leave it open, it's no longer a fire door because it's not going to stop a fire door going through. So ongoing maintenance is just as important as the original concept design. So passive fire protection. So it involves compartmentation. If you've got an apartment building, you're going to make each apartment a separate fire enclosure. You're going to make the escape stairs separate places. And you're going to have tested systems that someone has tested to make sure it's okay. The exterior cladding on houses, not really an issue, but as the buildings get taller, you're going to make sure your cladding is either non-combustible or a limited combustibility. Certainly there was a lot in the media last year after the Grenfell Tower fire, and I think this year we're going to see more in the media as the councils go through their survey of their building stock and start releasing their findings. I think Auckland Council's getting close to releasing its information, and the answers we find, we won't be squeaky clean. There will be things that need to be dealt with. And if you've been involved in the recladding space through to weather tightness, the solutions will be no cheaper than that, and so there will be no instant fixes or, it'll be a long drawn out process fixing these buildings. Not so much in these types of buildings, but smoke control. In bigger buildings, we're concerned about where the smoke goes and preventing it from going where people need to go to escape. Penetrations. So we build all these nice firewalls and floors, and then we get the plumber to come in, and the plumber cuts nice holes. The electrician cuts nice holes in our walls and puts their cables through. And maybe the best one is after you've completed your building, you decide you need a TV, and the TV installer comes and he has no idea about any of the fire rating you've put in your building, and he merrily cuts holes in everything. Or the other good one is you decide you need fibre because fibre's at the street, and Chorus will happily cut through anything and anything to deliver fibre just where you need it. And to be fair to them, there's no label anywhere telling them what they're cutting through is a firewall and they should do anything. I've got an apartment building at the moment where the building manager rang up a passive fire consultant and said, Chorus are coming and doing some work in our building, can you just come and check that they're doing it properly? And so he went along and he said, no, Chorus are doing it, they're doing a bad job, but I wouldn't be too worried about that. The elephant in the room is that every other penetration in that building is much worse than what Chorus is doing. So, I mean, it's good and bad because it's life safety, but the building manager thinking they're doing the right thing, checking up on Chorus, uncovers this project that maybe is worth $1 million to fix. There's a lot of apartment owners, so when it gets broken down to an individual owner, it's not the sort of fall off your chair sort of number, but it's money that you could have spent on something else. It would give you a nice holiday in Fiji or something like that. The last thing is structural adequacy, making the things that you fire rate stay up and stay in place. So when you get into apartment buildings, the structure is often separated from your walls, so we get involved in protecting those sort of things as well. Today, mainly I'm going to talk to you about the fire stopping, but we're going to touch on all of those aspects. So I want to talk about a design process. This really applies to all the passive fires within the buildings that you're dealing with. So I alluded to the traditional approaches, or maybe the traditional approach is a fire engineer writes a fire report, and if you're doing terraced houses, he or she draws a line on the page where the firewall goes and says that's a firewall. And that's the job done. They collect their money and they've written a fire report. Maybe someone looks at it and thinks, well, I better do something about that, but there's no discussion between the two. It goes into building consent and the council officer says on his checklist, fire report, tick, looks on the fire report, firewall, job done, consent is issued. The builder doesn't look at the fire report, looks at the architectural plans, and maybe the architectural plans intimate some things, but maybe not on the level of detail, and maybe they don't even follow the plans. I know when I said single houses that people want to subdivide, they're extreme, some of the hardest jobs to do. Often we get asked to go and look. The building inspector will go along and say, I think maybe you should just get a fire engineer to tick off what you're doing. And the first thing that we notice is the builder has been quite creative and hasn't bothered to has followed the intent of the architectural drawings that, yes, there's two dwellings and they're connected together, but how they went about doing the fire separation is, it's almost impossible to come along after the fact and fix it up. That type of scenario is It's a money-making operation for everyone involved. We spend hours and hours trying to figure out how to solve it. The people that get involved trying to put the solutions in, they charge lots and lots of money to do it. And in proportion to the total house build, it's just totally out of proportion. And from our perspective, it's really a lose-lose situation. You know, we're only going to go in there and make enemies because we're going to tell someone, A, they've done it wrong, and B, it's going to cost a lot of money to fix, and the owner is going to tear their hair out with the amount of money. So our preferred approach is we start right at the concept design. The concept design is where you can save the most money for your client. In the concept design, oh, my throat's a bit dry. If I keel over, only non-alcoholic drinks at this stage. A glass of water would be good. So, at the concept design, if you're just doing a house, where you site the house on the property can be quite important. If you're greater than 1 metre from the boundary, it's good. If you're doing 2 houses with a wall in between, there's also a 5 metre rule that if you're within 5 metres of the boundary, you don't have to rate the windows. Oh, good. But you do have to rate, the wall excluding the windows that is closer than 5 metres to the boundary. And that sounds quite easy, but you also have to maintain that wall standing upright, and that can be the challenging part. So even at concept design, you can make a lot of cost savings just by siting the building optimally on the site. You can't design out of everything, but if you have the best shot at the beginning. When we're doing larger buildings, we can get the overall strategy sorted out of how you might run services and how you might rate them. Then as we go through the design phase, we start to have more and more detailed talks. So if it's terraced housing, we might talk about what you're going to build your IT wall with. You know, there's many products on the market. And we've had hours and hours of discussions with people as to what's the best system to use. I don't think there is any one clear winner. Each system has its advantages and disadvantages. But if you talk about those early on in the design, you can come up with the best system for the building and construction methodology you're wanting to use. You know, sometimes your client is totally focused on lowest cost. Sometimes they want, if you're a developer, lowest cost can also mean the quickest construction time. So you might choose a low cost wall construction, but if it's slow and time consuming to build, it can end up being a greater cost. So it's quite easy to have those discussions early on in the design phase and come up with an optimum solution. When we get invited to look at jobs, when you're just at consent stage, there's a lot of time and money invested in the design, and if you say, oh, why don't you do it like this? No one really wants to change their design and waste their money redesigning. You know, the time is gone for that. It's just make the most of what you can do. When we come to passive fire protection, we start to look at individual systems that we make sure it works within the building. We don't leave it up to the builder to work it out. We leave it up to the builders and installers. We give them a design to build to. And as we get to consent stage, we make it easy for the council. We tell them what we're going to use. We give them the test results to support the designs we're going to use, so it's an easy tick in the box. There are many consents out there at the moment that the council just says, prove that what you've designed is going to work. Where is the test evidence? So we put a lot of effort into providing that up front to make the job go smoothly. And maybe the beauty of that is when you come to construction is just a checking and inspecting process rather than a designing on the fly. Because when you're trying to design on the fly, the builder is always wanting to do the next thing straight away. and they only ring up the day before that they're ready to line the wall to come up with a solution, and it's often not that easy. So just some examples of sort of drawings that we produce. We'll identify where all the penetrations are, and we'll give a schedule of how it's going to be done. It makes it very easy for people. And as designers, I'm sure you follow this practice with your own designing, so it's nothing new, but it seems to be when it comes to building services and penetrations, it's just a totally foreign concept. And I think maybe my background as a building services engineer, you designed things and then you inspected the design as it was constructed. So this is just applying that same sensible methodology for this aspect of building construction. And if doing this wasn't a good idea, you wouldn't all be here today in jobs designing things so that someone could build to it. So, what are the problem areas or the areas that you need to look out for? So, we talked about IT walls. They are fire rated, and so you have penetrations in those maybe or maybe not. I think a lot of the older buildings that we've looked at that have been reclad, there was no thought went into that. So cables went everywhere, pipes went everywhere, and there's a lot of money goes into doing them. And a common IT wall was either a single or a double stud timber or steel framed wall with plasterboard on both sides. And so every time you go into that, you might have to fire rate a penetration. And a rough rule of thumb for a cost of a penetration, if it's done properly, is sort of $60 to $100. So if you put a shower on an IT wall that needs to be fire rated like that, you've got two pipes, the hot and cold go on the top of the wall. So that's maybe you've used up $200. You've got a shower rose, $300, and you've got a mixer. A mixer's quite complicated, so maybe you're up to $500. But if you had shifted all that round the corner onto a non-fire rated wall, that's $500 you could have saved for your client. It's hard to make that change after you've got your building consent, but when you were in the initial stages of discussing with your client what you wanted to design for them, you know, that's an easy tick in the box often, money that can be saved for them. So I don't know that many people are building those types of walls now. You know, there's other wall systems that people have got that get around a large percentage of those problems. But again, it's early planning and thinking about that. The other area is the top of the wall. Unless you want to have a nice firewall poking up through the roof, some people do, but most often not. You've got to bridge that gap between the top of your firewall and your roofing material. And so, sounds easy, but it can be quite an expensive proposition if you haven't thought about it in advance. And then the other area is if you're just doing terraced houses, where your firewall comes out and butts up to your exterior cladding, something needs to be done to close off that cavity. And if you've got apartments one above the other, you've got a horizontal cavity where the floor comes out. And so that obviously puts us in conflict with what you're trying to do with weather tightness. You've got this nice ventilated cavity, and then a fire engineer comes along and says, well, I can't have that fire path going up, and I want you to block it off. So what do you do there? We're at a bit of a stalemate unless we can come up with some smart products to use. Another area is stability of walls. When you've got terraced houses and you've got an apartment on either side of your firewall, as long as your firewall is tied into both sides, you can burn down one side and it'll be held up by the other. But when you get to the end wall and you burn, so say for example, we've got the pointer going to go, say this wall here. If we had 3 in a row you could burn this, well, you could burn this down, but this apartment will hold that wall up. But if you burn that down, what's holding that wall up? And that's can be quite an expensive thing to hold up. We were doing a reclad on an apartment block, terraced houses like that, and there was just one apartment in the whole block. It was closer than a metre to the boundary, and it needed to be fire rated. Originally it hadn't had any stability built into it. So we said to the structural engineer, you need to hold it up. And so the structural engineer said, well, you could fire rate the ceilings, and you could fire rate all the walls to link into that wall to hold that wall up. But that's not really a fit for purpose solution, because if you sell someone a home and you say, by the way, 90% of those walls you can't touch because they're firewalls, you know, you constrain the future opportunities of people to change around their apartments. So then the structural engineer said, well, we could build a nice big steel frame and we'll bolt it to the concrete slab and we'll put some footings down to hold it up, and that will hold that wall up. And that was also an expensive proposition. And so numbers of sort of $50,000 to $100,000 to provide this structural stability. And so maybe that apartment was worth, maybe it had a value of $600,000. So to tell an apartment owner, it's going to cost you an extra $100,000 just to have the house back that you thought you had in the beginning, it's not really a palatable solution. We were lucky in that scenario that because it was an alteration, classed as an alteration, we could come up with an as near as reasonably practicable solution. And so we added some measures, but not a 100% foolproof solution, and the council were happy that we'd made the building better, but not maybe 100%. So there are some opportunities for that. The other areas that we have come into problems with, we had a person, they had their existing house, and over the top of their garage they wanted to put a granny flat, and the garage was sunken below the ground and the granny flat was on ground level, but the granny flat was 5 metres within 5 metres of the boundary. And so previously their single ownership house, all generously much greater than a metre from the boundary, no fire rating, no separations. And so then they put the granny flat on the top, so not too hard to do the fire separation between the granny flat and the house and the garage below. But then we had these walls that were within 5 metres of the boundary. So again, you know, the costs start to escalate for such it's just such a simple building, but you add a lot of cost and it's hard to see where the value is in it. But it was a process that we had to go through. And if the structural engineer had a thought of it right at the beginning, it's easy to put a post in and bolt it to the ground, but when you're near the end of the design process or in the middle of construction trying to do that, it becomes much more expensive. So early thinking about that is very beneficial. Post-fire stability for external rated walls. This one here, yeah, okay, so that's the 5 metre rule. So we have the 1 metre rule and we have the 5 metre rule. So that's just a diagram illustrating your 5 metre rule. Okay, so some interesting things about this. We've got this wall here. That doesn't go up to the height of this house, so this is above 5 metres, so it protrudes. When we're designing to the boundary line, not to the other building on the other side. So you could have a vacant lot on the other side, but you still have this thing that you're designing to the boundary. So a lot of owners find that a hard concept to get to grips with. You know, they'll say, you know, there's no one on the other side of the boundary. Why do I need to worry about these things? But it's the property boundary that we're designing to. so that the person on the other side, they are free to build whatever they want within their limitations. So we're always thinking about our property boundary as opposed to the building on the other side of the boundary, which can be a bit of a thing for building owners to get their heads around, especially if you're in the business of doing alterations and extensions to existing places. Other areas that we have, IT walls. They need to go down into the subfloor space. There was a house, a truck drove into it, and so it needed to be fixed up because the truck drove into it. As part of that repair process, they thought, well, let's put a firewall in, and we'll subdivide part of our house so that we can have an extra rental income. And it was on a timber floor, and so not too hard, not easy, but it's doable to get the floor up and up through to the roof. But the hardest part probably for the builder was the floor needed to extend down to the ground. And so there was a gap of around about 400 to 600 under the floor slab with all the joists filling that space up. So they had to crawl underneath, dig a footing, put a concrete footing in, and then their solution was they were going to use concrete blocks, but whether you're using concrete blocks or your timber framing and then lining with something like fibre cement board, you know, it's not an easy task to get all that detailed work when you're working in sort of a 400 to 600 millimetre space. And I'm sure the builder charged a premium for that sort of work. And maybe, I don't know, if he was smart, he would have stuck the apprentice down there to do that job. But yeah, so those little things can catch you out, particularly if you're in the concept stage and you're trying to put budget costs together for your clients. All these little things start to add up to big numbers. And so if you can front foot them and say to a client, yes, we can do this design for you, but there's these and these problem areas that we need to solve. I always find that if a client is forewarned and they know up front, they can make an informed decision. But when you're halfway through the build process and the building inspector comes in and he says, well, where's your fire rating underneath the floor? And you have to go to your client and say, oh, well, that's an extra $20,000 on the budget. There's no winners in that scenario, whereas if you spent maybe $500 in the beginning of the design process fleshing these things out, you got yourself covered up front. These IT walls, fire-rated IT walls that we put through the building, they need to extend out to the eave. And so if you leave that to the builder to figure out, most buildings I've seen, the builder comes and does his nice fire-rated wall, and then he puts the roof on and the eaves extend out, and no one thinks about the fact that the fire gets into the ceiling, runs through the eave, and then comes out into the next house. And so that needs to be thought of. Often we're on building sites and the roof has gone on and the soffit has gone on, and we're just asked to come in and check that nice bit of firewall, and we look above the ceiling and we say, well, what about that bit there? And so the builder says, well, how can I do that now? And we say, well, you could take the soffit down to get access to it, or you could take a bit of the roof off. But the builder knows that the roofing contractor is a separate subcontractor, and if he asks the roofing contractor to take a bit of roofing on, the roofing contractor is going to ask for some more money to turn up on site to do that because he's finished. And if you ask him to take the soffit down, you get the same answer. And he hasn't allowed to do that little bit in there anyway, so he's on a lose-lose scenario. And so then we have an argument with the builder as to why he should do it or why he shouldn't do it. And so we have this toolkit of standard answers to tell people, And if it's, if it's for an individual client, then we have to tell the individual client why they're spending more money. And it goes through the whole explanation scenario. Sometimes you have external walls that are fire rated, and a common exterior product is fibre cement rag board. So James Hardie don't really have any tested systems for the penetrations that go through their products. So if you want to put a tap on the outside wall, or you want to have a rainwater head overflow, it's not just a matter of sticking it through and going to Bunnings or Placemakers and getting a tube of sealant that says 4-hour fire rating and squirting it round and job done. So Bunnings and Placemakers, it's an all care, no responsibility scenario. The label says fire rating up to 4 hours, and then on the fine print it says to be applied in accordance with the test data or manufactured instructions. And if you look on the shelf where it's sold, that data isn't available. If you go on the website, you may find it. But if you're a builder running in to buy a tube of something to solve the problem, you don't then go back and look up on the computer and look on the website, and it says this product is suitable for up to 4 hours if you're filling up a gap between two bits of concrete wall. And this is where I've tested it. If you're using it anywhere else, I make no claims to its performance, and you're on your own. I mean, there are products that do a variety of things, but just attacking it at that simple level, the chances are that you will get it wrong. We had a client recently that, not really to do with passive fire protection, but if you buy a property that's got a long driveway that it takes further than from the street to the furthest place in the property, greater than 75 metres, which is a fire service hose run distance, you have to put sprinklers in your property. So we had a client that came to us and said, well, we bought our property and we're ready to build, and we need to put sprinklers in. Well, we don't want to put sprinklers in because they're hugely expensive, but we've just realised that we need to put sprinklers in. And our whole cost scenario is not putting sprinklers in. So when you go and add that cost to our build cost, our profit margins really get squeezed. What can you do about it? And so we said, well, we've been through that process before with the council and the fire service, and that's what you have to do to solve the problem. And so he started shopping around until he found someone that said, no, I don't think you need to do that. And so we said, well, what can we say? We said, well, you can go with that fire engineer. I think the sad fact is, if he was really, really lucky or unlucky, as you might, depending how you look at it, if he's really lucky, he will get his building consent because the processing officer is focused on the KPIs, and you get the consents through, you get a tick for the most number you process. He gets on site and the building inspector doesn't ask him any questions. He builds the building, gets his CCC, job done, and no one knows about it. But anywhere along that process, he could get picked up on that it's a failure. So his designer could say, yes, don't need the sprinklers. He could get caught up at the building consent stage. He could get caught up by the building inspector during construction, or he could get caught up at the final code compliance certificate stage. And we've had many examples of where people get pulled up at code compliance. And maybe with council sort of gun shy when they realise they've stuffed up. They don't really think about the downstream consequences. They just say, well, it's got to be fixed. Don't care how it's fixed, but it has to be dealt with. So if you're a developer and you're quick to market as part of your strategy, if you're at CCC stage and suddenly you've got to go back and retrofit a sprinkler system, which means digging up your driveway to get the pipe in and pulling bits of walls down, it's quite an expensive proposition. So that's sort of the hard stuff, but what are some smart ways of solving some of these problems? So, inter-tenancy walls. You know, concrete and concrete block has been a traditional method. Much easier if you have to go through, you can easily fire rate penetrations, but it means if it's strapped and lined, most things on apartments, they don't actually go through, they're just going in, down and out the other side. So you don't actually have any fire rating problems. Speed wall is another one. You know, that works on the same principle, strapped and lined, so you don't need any penetrations going through. On the jib board line, Wintstone, Jib and Borrell, they have their systems where they have a thick jib or plasterboard product that goes through the centre, and then they're strapped and lined on the outside, so all your penetrations are on the sacrificial wall on the outside, and you don't need to fire rate any of that. So if you think of, you know, say a townhouse and a terraced house, it might have 2 bathrooms. You stick them on the inter-tenancy wall to make it, you know, because you don't want to use up premium space. You could be sort of, you know, maybe there's $2,000 or $3,000 you've saved per bathroom for that price. We did an apartment project and we worked out the total cost of the passive fire protection. That was all the penetrations going through the floor, through the walls, the cavity barriers around the wall and between the wall and the roof, and that worked out at $8,000 an apartment. So that's quite a hefty sum. Through smart thinking, you can save quite a substantial amount of that money. So here's sort of your shower scenario. You got your mixer, you got your shower rows coming out, you got to have your pipes coming down somewhere. So all those add up. Same goes for basins. You got a hot and cold water pipe, goes in the wall at the top, comes out at the bottom. So you've got at least 4 penetrations, and then you've got a waste pipe that's going to go somewhere. Maybe you're going to poke that back in the wall. So you've got 5 penetrations. Okay. Decks are a thing that we get caught out on from time to time. So if you're doing single or terraced houses, a timber deck seems to be an ideal scenario, but often you want to get the deck close to the boundary, or it could be you want a carport or a car deck because you're on a sloping site, and so the timber that's close to the boundary becomes a problem because it doesn't comply with the surface finish requirements for spread of fire and its combustibility. So if you can have, you can face the timber with fibre cement to improve your surface finishes. You can, if you can have a glass or steel balustrade, you get rid of your combustible material. Sometimes you can use steel in there, but thinking about that in advance, hard to solve that problem when the building inspector comes along after you've built the deck and says, I think there's a problem here. The other one is eaves. The eaves need to be greater than 600 millimetres from the boundary to not be fire rated. An eave is not too hard to fire rate, but if you have to fire rate the eave, then you need to fire rate the wall that's holding the eave up. And so what starts out as a small cost ends up with a big cost that you end up trying to fire rate a whole wall just to deal with a little bit. And often the eave might be 550 millimetres from the boundary. And so if you had I know eaves are important, but sometimes maybe you can think through whether you do actually need that extra 50 millimetres or whether you can delete that 50 millimetres. If you can delete that 50 millimetres, you can save your client a lot of money. the providing stability for walls. So Jib have some simple solutions, James Hardy have some simple solutions. Easy for single story, gets more complicated if you've got a 2-story building because it's hard to hold it up. You can think of something that's very high that you're trying to, it just waves around in the air once you've burnt the rest of the building down. So once you get into 2 stories, you often need to get the structural engineer involved to come up with a system to help you design that. Sometimes you can tie the IT wall back into another wall that is already fire rated. So one structural engineer, he was going to put a beam between the boundary wall back to a wall on the other side that already had the stability, and so that was just going to stop it from falling over. He said it didn't matter if it flapped in the breeze, all it had to do was not fall over after the fire had burned through. So talking early you can come up with those solutions. Vertical spread of fire. So surface finishes. For CAS1 designs, you've got up to 10 metres, you've got no restrictions if you're greater than 1 metre from the boundary. If you're closer than that, you need to start thinking more carefully about it. So I suppose if you have a 10.1 metre high building, life would be much easier if you can maybe change the pitch of the roof and go down to 10 metres. I think we will see some change on that 10 metre limit. For some buildings it makes sense, but other buildings it's maybe an overkill. So last year there was a round of discussions by MB on a variety of things, and one of these things was surface finishes. And there was a lot of feedback that the rules that they've put in place, while they might be nice and safe, not every building is risky as every other building. And so maybe they've sort of cranked the dial down too hard on some projects. One example that springs to mind is a school hall. It might be 11 metres high or a gymnasium, but essentially it's a single story building. But you get hit with all these exterior cladding restrictions, whereas in real terms it doesn't really make any difference whether the building was 10 metres or 15 metres high, because the people are all on the ground floor and they're going to get out quickly. So I think some stage this year we'll see some more clarification, and there'll be some areas, particularly for timber cladding, that we'll be able to use, be more flexible with how timber cladding is used. But it's certainly worth being aware of that. The other one I've got up here is the cavity barriers. So what we want is in conflict with having a drained ventilated cavity. So there are products, they're called intermittent products, and they expand on heat. So when in their natural state, they might be 5 or 10 millimetres thick, but when they heat up in a fire, they will expand to sort of, they can go maybe 50 millimetres or 100 millimetres. And so you can have both examples the same. Here's a design scenario. So this building here is a terraced house, and the IT wall goes right up the ridge line. And so what the acceptable solutions say is that you have to protect spread of fire from a lower roof on one property to the next property. So this little bit of lower roof here, you can have spread of fire from that lower roof onto the upper wall of the neighbouring property. This is it's a very minimal extension, maybe 300 millimetres. So to meet that criteria, we fire rated the underside of the roof, we fire rated the underside of the eave. We then had to hold that bit of roof up. So we had to fire rate this wall structure there. We had to fire rate the posts. We had to fire rate the joists that went right back inside the building on that level to hold that up. Then we had to fire rate a bit of this wall here to provide stability to this bit of wall here, which was holding the little bit of roof up. So what looks like a nice architectural feature was hugely expensive. Doesn't show it on this particular one. I think this one, the builder had learnt a few things after that one, this one here, because he'd done a few others. So the first one he did, the plumber came in and he filled this wall up full of holes. And so that added maybe another couple of $1,000 to that wall. Then he needed ventilation. So he took his vent pipe out here, out through the soffit. And I don't know, that was a hugely expensive thing to fire rate. So that might have been a couple of $1,000 solution. Whereas I think later on, he took his vent and he took it somewhere else that had no fire rating. And so that was, that was just coordination on site. The builder knowing what needed to happen, talking to the plumber, talking to the ventilation installer, and just trying to avoid all those trouble spots, made it much cheaper. And if we were only, engaged to just do the construction monitoring on this, someone else did the fire report. And so the fire report did intimate that that needed to be fire rated, and the architect had done what the fire engineer had said, fire rate the underside of the ceiling, but the fire engineer had omitted to really point out the implications of fire rating that bit of ceiling. And I think if the architect had known in advance what that little bit had done, he might have designed differently. I think sometimes, speaking to some architects, we do get to talk to them early. Is it when you go for your resource consent, the town planners are quite keen on, some visual difference in the facade of your building, so they're quite keen on these little things. Oops, wrong button again. They're quite keen on these nice little fancy features. They're costly. There must be some ways to do them much cheap, get the same effect without the same cost, but it does involve marrying up, what the goal of the looks are, and marrying that up with what it takes to do it from a fire perspective. There must be ways of doing it cost effectively, but if you do it at the last minute, it doesn't really work at all. Okay, so I think my final thoughts are design during the design stage and build and check during the construction stage. Don't try and leave it up to the builder to design during the construction stage or someone else to design during the construction stage. I'm sure you don't do that with your designs. You don't expect to design the building after the builder started working. And so for other aspects, it's important to do those things at do those up front, have those conversations early on. At the concept stage, they don't need to be expensive conversations, and they can certainly pay for themselves if you get the right design going forward and can make life easier. So that's the end of my presentation. Any questions?
Yeah, Mike, what are the comments about houses further than 75 metres up right away requiring sprinklers? There must be a lot of existing houses that are down right away longer than 75 metres that don't have sprinklers at the moment.
Yep.
So how do they fit into the picture?
Well, if you've got an existing building, you don't have to update to the building code current.
What about a rural property?
Rural properties, I haven't done many rural properties, but often they will get asked to put a domestic sprinkler in, so that means they need a tank and a...
I've done most of my work's rural residential.
Right.
I've never been asked to put a sprinkler system in. And just about, lots of them are longer than 75 metre driveways. I find that very hard to believe.
You're asking for water tanks
So, okay, so the other thing is your driveway. If you've got a driveway wide enough, the fire service can get down. So these ones, they bought properties with narrow, say, 3-metre driveways, good enough to get a car down, but they couldn't get a fire truck. So if the fire truck could drive up to the front door, the fire truck has 135 metres of hose they can get back to the street main, but in your rural ones there wouldn't be a street main, probably would there? No. So sporadically applied, but more diligently applied these days than in the past. Yep.
Maybe commission about providing structural stability after the fire.
Yep.
If I've got one at the moment where it's 2 dwellings on one site, but they're just a bit more than 5 metres from your boundaries. They still have to go.
So you're saying just a bit more,
So it's about 5.5 metres.
well you're fine, don't need to do
So
anything.
don't have to.
No. The 5-metre rule, I'm not quite sure where it is coming from. It seems a bit nonsensical sometimes.
Especially since it's about 10 metres high.
10 metre, yeah, that's right. Yes. So if you go from 5.5 to 5, why does that get any more dangerous? You know, your 10-metre wall falling over at 5.5 metres, maybe that's going to fall on the neighbours. But why going that extra 500 millimetres suddenly makes it safe? It doesn't necessarily stack up. Yep.
So that 5-metre rule, so in a single house zone in Auckland, they allow the 9 units, and so we've got normal sites, we put a mining unit on, so does that have to be fire rated, because it's going to be well within 5 metres of the site?
Is the minor unit attached or detached?
Detached.
Detached. Okay, so minor units still treated as 2 separate dwellings.
So that it has
So-
to be entirely fire rated.
No, so you've got your 1-metre rule.
Oh, okay.
Yeah.
And if it's attached, it's
But if it's attached, that's where the 5. But remember, if you've got two dwellings, you need 2 metres separation between them. Each has to have its own 1 metre.
You mentioned 600 millimetres to you effectively.
For the eave, yep.
Are you talking about faciable or the gutter? Faciable gutter.
I don't think that's clearly been clarified, but I think it's the fascia board normally,
The council asking for the gutter as well.
the gutter. And so if you have a non-combustible gutter,
Some cases.
yeah,
on the process.
yeah,
Yeah, council gutters.
yep.
When you prepare a fire report or someone comes to you with a building and says, well, basically needs the council's fire report, do you identify which walls require to have post-fire stability assessments
Yeah,
as part of that report? Would you normally do that?
yeah, we would. We couldn't necessarily tell you how to achieve it,
No.
but we would tell you, and then we'd either work with you or your structural engineer, depending how complicated it is, to solve the problem.
At what stage would be the best stage to bring the plans to you? Like if we don't want to see in the multi-unit.
We personally, we think the concept design, because if you come to us after you've designed it, and we say, well, here's a good idea, you'll say, oh, but I've spent my money designing it, why should I? Good idea, but I'm not going to change my design. So it's those early conversations. You know, if you want to have a discussion about what's the best IT wall to have, you know, best to have that conversation before you draw it on your drawing, you know, while the IT wall is just a line in the page. And you don't need to write I think maybe sometimes when people go and ask a fire engineer for a fire report, they get a fire report, but maybe what you wanted wasn't a fire report, you just wanted to have a discussion about your building. And so maybe it's better to just say, I just want to come and show you my plans and have a discussion and pay you for a couple of hours' time, and then maybe there's no issues, I'll just go away and job done. Or maybe then we map out a plan of what you do need to do. Because some of these simple buildings, you know, maybe you just have a discussion in the beginning and you go away and design it, and then right at the end you say, now I think I need the fire report, and you can just have the fire report that says firewall line on the page, because you've already thought about all those other issues and you've solved them. Yep.
Have you had many inquiries from people wanting to say they've got a home, they've got a garage, they convert it into what they call games room that you know very well have every intention of renting out as Airbnb?
Do we have people come and ask us that?
You must ask me.
I don't know whether people, I mean, I've seen that going on.
As a designer, you need to advise them that, if their intention is to rent it out, then space should be sacrificed.
Yeah, okay, so I haven't had quite the garage, but, someone says, I want to just have a separate space because my grandmother's going to come and stay, and I'm going to put a kitchen in or something fancy, and we can't force them to do anything, but we can flag up that, mate, your grandma's going to die some stage, and you've got this nice place. The most logical thing you're going to do is rent it out. And now, if you want to put some fire rating in, now's the time to do it. Yeah, so we've had clients like that. Yeah, what was one? They had a 2-storey terraced house, and they decided that their parents were going to come and live with them. And they were, maybe it was the garage downstairs, they were going to do that up. And so initially, we had some discussions. They said, well, is it okay if our parents come? And we said, well, if you're operating like one household unit, that's fine, don't need to do anything. And we alerted them to, but if you do something in the future, it's going to be expensive. And, you don't know what clients tell you. And we just said, well, here's a money-making potential here. If you do the fire rating now, maybe your parents don't like living with you. They can't stand you.
Even if your parents, even if it is your parents, you've still got, if it's got a kitchen, still got to treat it as a separate dwelling. It doesn't matter whether they're your parents or someone you're renting it to. That's the way the council.
The council said. I think if you've got access between the two places and you can show that you're living.
As soon as you put another kitchen, it becomes a minor dwelling.
Do they call that a minor dwelling?
Council is going through that.
So what happens when you put a microwave in a?
Sorry?
What happens when you put so I've seen you put a microwave and you put a basin / big enough to be a sink.
Depends on how the council think about it.
Council's all different too. Like my category says if you put in an oven, it's a separate kitchen, whereas Rodney said it's got a sink and it's a separate kitchen. They're changing, they're exchanging the kitchen.
Okay. So I think we just try and alert people. We can't tell them what to do. If they make that decision, they make that decision. But we try and tell them that, at least point out that if you want to rent it out, you do. If you want to be legal, you've got to fire rate it, and good to do it now rather than later.
Cool.
Sorry,
Last one.
if you've got a minor unit and it's within 2 metres of your primary unit, does that mean you have to fire rate both sides of the roof, the interior and the exterior?
If it's within 2 metres. Okay, so if you're within 2 metres and you've got 2 units, one's the main dwelling, one's the minor dwelling, what you could do, because you've got an existing house that's got no fire rating, because it had plenty of distance, you could fully fire rate your new one, and so that would solve that problem. And so you could say the boundaries, you could then squeeze them up to a metre. Yeah, that would be the way to go.
I think we need to wrap it up there, guys. We've still got another presenter to go. So thanks very much, Michael. Token of our appreciation for coming along. We'll take a quick 10-minute break and then we'll be back for our next speaker, guys.